Hello guys, today I will discuss about confounders. Next video I will discuss difference between bias and confounders. One researcher had a research study on a topic that coffee causes increase in heart disease. For that he collected a sample of 2000 people consisting of 1000 people who were coffee drinker and 1000 people who were not coffee drinker. He found that among coffee drinker 37.4% had heart disease, while among non-coffee drinkers, 17.6% had a heart disease. Hence, the coffee drinker has 2.12 times the risk of heart disease compared to non-coffee drinker. Someone suggested the researcher that age could have been the confounding factor. Luckily, the researcher had collected the age of the people too. Heart disease specialists told him that people above 60 years are at increased risk of heart disease. The researcher categorized age into two groups, more than 60 years and less than 60 years. The researcher decided to compute the rate of heart disease for each category of age in both exposed coffee drinker and unexposed, which are non-coffee drinker group. Now the rate of heart disease is different when categorized by age. In both coffee drinker and non-drinker, risk of heart disease in people above age 60 is 50%. Now the researcher wants to calculate the age-adjusted relative risk of heart disease with coffee consumptions. For that, he calculates the rate in each label of the confounding factors. We see that rate is computed for both category of age for both exposed and unexposed group. The researcher knows the distribution of people by age group. Here we see that total people in age category more than 60 are 802 and total people in age category less than 60 are 1198. So there were total 2000 people. This total number is same as in previous table. We see that the people with age more than 60 is 666 plus 136, which is equal to 802, and same is for age less than 60. Now the researcher multiplies the rate of heart disease by standard populations of each category of age for both coffee drinker and non-coffee drinker. Such multiplication gives the hypothetical number of people with heart disease for both age category for both exposed and unexposed group. Now researcher calculates the age-adjusted risk of heart disease among coffee drinker as 401 plus 147 divided by 2000, which is equal to 0.274. Similarly, he calculates age-adjusted risk of heart disease among non-coffee drinker, which is equal to 410 plus 150 divided by 100 divided by 2000, which is 0.28. So age-adjusted relative risk of heart disease is equal to 0.274 divided by 0.28, which is equal to 0.98, which is approximately equal to 1. So, without taking age into account, risk of heart disease with coffee consumption was 2. But age-adjusted relative risk of heart disease with coffee consumption is 1. Hence, researchers conclude that there is no added risk of heart disease with coffee consumptions. Here we estimated standard population by summing up number of people in age categories. But if you know the distribution of confounding factor in a whole population, the standard population has to be used. Before ending, I'd like to define confounder. It is a variable that affects the relationship between the independent and dependent variable. Confounders should be related to both independent and dependent variable. Outside variable, which only affects dependent variable, is not a confounding variable. It is known as an extraneous variable, but not a confounder. In our case, age is related to coffee consumption because as age increased, people were found to consume more coffee. Age is also related to heart disease. You can say high cholesterol also increases the risk of heart disease, but high cholesterol is not a confounding factor for this research, since high cholesterol and coffee consumptions are not related. And lastly, before concluding, I will say that confounder can be accounted during data analysis as we have seen before. Thank you. Please like and subscribe.